Alright guys, here's some questions, or I should say some of the work done for some common questions from the previous homework assignment. So take a second and take a look at those. You can pause the video and check out the work. So today we're talking about arc length and area of a sector. These are actually, two pretty simple concepts most people don't have a problem with. So arc length. Here's the basic definitions. Arc length is related to circumference. Basically, you're just cutting out a piece of circumference. And so you have two different equations based upon what unit you're using. As you'll notice, both equations have the 2 pi r in common because it makes sense that this is based off circumference. Where the difference comes in is whether it's out of 360 or 2 pi radians, and that's solely based on whether your central angle is given to you as a degree or a radian. The equations in the book are a little bit different, and I think it's a little more complicated that way. But if you look at the book and you like that way better, you can do it as that as well. Alright, so here we just want to find the arc length. We're given that theta is pi over 6. Oops, that's not supposed to be there. That's supposed to be hidden. I have to fix this. So in this case, what you would have is the arc length would equal theta. This is in radians, so it's theta over 2 pi. And then 2 pi r. When anytime you're using this version, you can cancel out the 2 pi's. Makes it way easier. So it's theta times r, so that's pi over 6 times 2, which gives us pi over 3. That's our answer. So, pretty straightforward. Area of a sector. Now we're looking at something that's like the area of a pizza slice. Once again, you'll notice, since we're talking about area, it's the area of a circle now. The only difference between the equations is whether that front ratio, this first fraction, is in terms of degrees or radians, based on your central angle again. So we have the area of a sector, the radius is 3 feet, central angle is 240. So I have 240 degrees out of a total possible 360. That's our ratio. Times the area of the circle, which is pi, times our radius, which is 3, squared. So here, 6 goes into both of these. 6 goes into 240, or 60 goes in there 4 times. It goes in there 6 times for 360. Equals pi, and times 9. Oops, that's not supposed to be an equal sign. That's supposed to be multiply. Sorry. So then, let's see what else we got here. We can cut this in half to 2 and 3. Take out a 3 from the 9. You would end up with 2 times pi times 3 is 6 pi. That's it. Like I said, it's pretty easy. You just gotta make sure you're taking your time and working through it. Alright, so here's a word problem type. So here we have a water irrigation arm, 500 meters long, rotates around a pivot point once every day. Approximately how much area is irrigated every hour? So now, what we're going to do is we're going to modify that front ratio. So before it was theta out of 360, where 360 is a full revolution, and that was a part, what part of the full revolution. In this case now, a full revolution would be 24 hours because it says it's rotating around the pivot point once a day. So it's every 24 hours, and we want to know how far it's gone in 1 hour. And then it's still times pi, and this is an area, so 500 squared. So then you would simplify this, and magically it should come out to be 32,725 meters squared. Alright, try this one on your own. We'll go through it in class, but I want you to see if you can figure it out. Give it 5-6 minutes and see if you can use just the basics from this video and understand what's being asked here. That's it. Hope this makes sense. See you guys tomorrow.